Assalamu alaikum dear students, I am Engineer Abdul Basit and we are in week number 11, lecture 22 of Geotechnical Engineering 1. So the topic we are going to discuss here today is soil classification. Uh, Before going to soil classification, I already told you that there are different types of soil structures available, and the soil structure depends upon different parameter. Okay, so these parameters were like the size and shape of the particles, the ingredients present in the particle, and the water present in the particle. Okay, but coming to soil classification, it's the same way. You can say that the classification of soil is also based on different parameters. Okay, like in the same way we discussed the soil structures. Okay, so soil classification means the soil is being classified in number of groups, okay, depending upon some of its properties. Mainly those properties are its liquid limit, plastic limit, and then its size, okay, sieve analysis or the particle size distribution. Okay, so first of all, how can we these are like different types of soils available. Okay, you can see in different containers we have different types of soils. So all the soils have different types of color and also texture, and their like size, the particle size distribution and the arrangement of the particle is all different. Okay, so that's why you can say that we have multiple types of group of the soils available. Okay, and all the groups of the soil are being used for different types, are like having different types of properties and can be used for different purposes. Okay, what type of properties can be affected by this classification? And like this classification is based on, already I told you, soil particle size distribution, liquid limit, plastic limit, mainly these things. Many other things are also included. Okay, but how these classification affect the properties of the soil? So it affect the properties of soil, like what will be the shear strength of the soil, whether this soil is good for irrigation or it's good for construction, whether it is like good for mat foundation, good for shallow foundation, good for deep foundation, what type of foundation should be preferred in what type of soil. So already we have divided the soil in, or classified the soil in different groups according to the parameters, and then these groups are further like explained for its properties. Okay, so like talking about it in just having this picture, so it will not be enough. Let's go in detail further what type of classifications we have. So in this book we are having three types of classification. Number one, we have this textural classification, and then we have the AASHTO classification and unified classification system. Okay, before coming to the textual classification, let me tell you that all these classification systems available till now are not like enough to classify the soil according to our needs. Okay, uh, these classifications cannot fulfill our needs and are not like explaining all the properties of the soil. Okay, but still we have three types of classification systems. So let us discuss this textual classification first. So as the name indicate, that in this type of classification the soil appearance is the main target. Okay, the texture of the soil is main target. Okay, so the texture refers to surface appearance, already it's like clear. Okay, so the textural appearance mean what type of soil we have, what type of feeling we will have when we pick the soil in our hand, and what type of feel we will have on our hands, whether it will be granular, whether it will be silty, whether it will be sandy, what type of soil we will have. Okay, so this actually explains the texture of the soil. Okay, when we have that clay, silt, sand, gravels. Okay, this is like particle size distribution. Okay, but one is textural classification. Textural classification mean sandy clay. It is clay, but it is having a sandy uh, um, feel when it is packed in hand, okay, and when it is washed closely, okay. So then this mean that clay is having sandy appearance, and then we have the silty clay. So it means this is a clay with having silty appearance, silty texture, okay, and so forth. There are many other types of textures available. Okay, so I hope you got the point and the difference between particle size classification and texture. Texture refers to the appearance of the soil. Okay, so here is the like nomenclature for the appearance: sandy clay, silty clay, and many more. Okay, this is the chart for textural classification of the soil, and it is very easy to use it. Okay, what type of values we have on this chart and how to use it? So let's do it. First of all, on this baseline, you can see on the x-axis, you can see we have the percentage of sand. Okay, so it is like increasing from right to left. This is 10, 20, 30, and so on up till 100. Okay, on this left axis we can have the clay particles percentage. Okay, so 10, 20, 30, and so on up till 100. Okay, so it is from bottom top increasing, and then we have silt percentage, so it is increasing from top to bottom on this axis. Okay, so we have this type of situation on the chart. How to classify different soils? So first of all, take the soil sample and perform its sieve analysis. So after sieve analysis, you will come to know how much percentage of sand is available, how much percentage of clay is available, and how much percentage of silt is available. Let's say we have this type of situation, that we have an A soil sample and it is having 30% of sand, 40% of silt, and 30% of clay particles. So how to classify this soil according to this textile classification chart? Okay, so simple. Let me tell you before going to that classification and that practical example, let me tell you that all these blocks, like this block is shown in like cream color, and this cream color block shows whenever the clay particle the clay sample properties fall in this block, so it means it will be clay. Okay, when the soil properties fall in this red block, this will be sandy clay. Okay, this blue color shows that in this block is silty clay, and so on. So these colors are actually for simplicity, but actually the situation will be like this whenever you have it in your design assignments or on your paper. Okay, so before going to that practical example, let me tell you one thing more, that is a sand size will be 2.0 to 0.05 millimeter, or you can say it other way, that 0.05 to 2 millimeter size particles are referred to as sand size with having this much diameter. Okay, and those particles having diameters range between 0.002 millimeter to 0.05, that is silt size. Okay, and similarly we have that clay size which is like smaller than 0.00 millimeter size diameter particle. Okay, so this will be simple to obtain the different types of sand or clay or silt percentage from the sieve analysis. You will judge it according to these sizes. Okay, now coming to this practical example, let us consider we have a soil A that is having 30% of sand. You may say that the particles with having this much diameter are totally 30% of the total sample, and 40% of the silt, okay, and 30% of the clay size particles are present. Okay, clay size particles refers to particles having size smaller than 0.002 millimeter diameter. Okay, so this type of particles having smaller size than this 0.002 millimeter are of 30% of the total sample. Okay, then how to find out the type of the soil from these properties given? Okay, so first of all, 30% sand, look for this axis, 30% on this axis, that is here it is. Okay, let me plot it particularly. Okay, uh, simple, you can see this 30% is the size of that clay particles. Okay, let me change the color as well to make it a bit more visible. Here it is, and you can see it. This is that 30% sand available. Now coming to this thing, we have this 40% silt. Okay, so 40% silt mean where it is, this is that excess of for silt. Okay, so 40% refers to this point, this is silt. Okay, then coming to 30% of the clay is like present over the here in the sample. So 30% of clay, this is the point. Okay, now draw, or you can say extend this point first of all horizontally. This is how to do it. Okay, this point can be like extended, like this 30 can also be extended in this way. Okay, here it is, in this way it can also be extended because the line also goes in this direction. Okay, similarly this line can be extended in this way. Okay, and similarly in this way. Okay, these two types of lines can be drawn. Okay, so let me do it in this way as well. Okay, similarly this 40 can be extended horizontally along this line. Okay, and can be extended along this line. You can see these blue lines. Okay, from every point you can see that there are two lines extended, one horizontal and one this inclined line parallel to this line. Okay, similarly from this point you can see one horizontal parallel to this line and one inclined parallel to this line. Okay, so you will have this type of situation all over. Okay, now you can see that these, let me draw it again. I am removing this thing first of all. Okay, here it is. You can see that one line extended from the clay is passing like this one, and 40 is passing like this one, and from 30 the sand excess is passing through this point. So you are getting like a new position over here, and that is let me show it in black. This is that point you are getting over here. Okay, so this point falls in clay loam. If it is visible to you, this point actually falls in clay loam. Look at here, this is clay loam soil. Okay, so you can say if a soil is having this much sand, this much silt and this much clay, so this will be a clay loam according to textural classification system. Okay, I think this is quite clear now from this this example. Okay, moving ahead, let me close it first. Moving ahead to the next slide. Sometime you may have a situation a bit different one, and that will be like, for example, if you have a soil that is having sand 10%, 30% silt and 40% clay, but 20% gravel is also available. Okay, so the chart is only developed for those particles which are passing through sieve number 10. Okay, not for those particles which are passing through, which cannot pass through these this 10 number 10 sieve. Okay, so if in case we are having a soil sample and it is having gravel particle as well, and that is not passing through sieve number 10, so how to use their chart, textual classification chart for this type of soil? Okay, so let me discuss it. Like for example, we have this this soil B. Okay, and that is not passing through sieve number 10 particles or 20% which are gravels. Okay, so basically these 20% particles are not passing through sieve number 10. Okay, and 10% sand particles and 30% silt particles and 40% of clay particles. Okay, so as I told you that this textual classification system or the chart can be used only for sand, silt and clay, not for gravels. So you have to remove these gravel particles from the sample. So it is not like to collect their gravel particles and throw it away. It shouldn't be like that. It should be done according to this a numerical calculation. Okay, how can you do it? You have to convert these gravel particles in sand, silt and clay particles. How to do it? The sand particles are like actually 10%. Okay, but 10% means 10 multiplied by 100, so 10%. But the percentage of the sand after 20% of gravels will be like calculated by this formula, that is 10 is the percentage of sand multiplied by 100 divided by total percentage is 100 minus 20. What is this 20 actually for? Gravels. Similarly for 30% silt, so silt size can be calculated by 30% silt already available. Okay, multiplied by 100 is the requirement of formula, 100 is the requirement of formula, minus 20 is for gravel. If this gravel percentage is 30%, then you will use 30 over here. Okay, similarly for clay, 40 is actually the percentage of clay multiplied by 100 is the formula requirement, 100 is the requirement of the formula, and this 20 is actually the percentage of gravels. So ultimately after removing this percentage of the gravels, you will get the sand size equal to 12.5%, 37.5% and 50.0%. Okay, so now you can use these values to find out whether where this type of soil is actually falling in the textural classification chart. Okay, so move backward. Sorry, moving here, you can see if we have that type of situation, so you can see that sand is here, silt is here and clay is here, no gravel excess is here, so that's why we have subtracted this. Okay, now you can do that process as we have done it for soil A, again for that soil B, and you will find it out where it actually falls in. Okay, and then the result will be like gravel soil. Okay, you will say whatever that is, you will say the gravelly silt or gravelly loam and all that. Okay, coming to this example, how to do this type of calculation for practical reasons. So classify the soil, the following soil according to USDA textural classification. So this is that United States Department of Agriculture. So definitely you have like different types of soils available, soil sample A, B and C and D. Okay, and all these samples are having different types of percentage of gravel, sand and silt and clay. Okay, all these are having different situation, but if you look at all these samples, you will see gravel are present all over here except this C1. Okay, this C, except this one, it is having gravel equal to 0%. Okay, so this C will be like simple to calculate, and straight away you will pick the chart and will plot this 18 and 20 and 58, and you will find out what type of clay it is actually. Okay, but for A, B and D, you have to actually go through this formula first. Okay, so how to go through this formula? Here it is, the formula given for all types of clay. You will repeat this formula. I'm not going to solve this numerical, just I am going to tell you how to do it. Okay, modified percentage sand, so simple percentage of the sand that can be calculated like, for example, it is 30%, so 30 multiplied by 100, and this is 100, so this will be percentage of gravel. So talking about the clay soil 1 sample, so gravel is 10% and sand is 20%. So in this numerical, this will be 20 multiplied by 100 and this will be 100 minus 10. Okay, multiplied by 100, you will get the modified percentage of the sand. And similarly for silt, percentage of silt, where it is, this is silt 41, so 41 multiplied by 100, 100 minus 10. Similarly clay, here it is 29. Okay, 29 multiplied by 100, 100 minus percentage of the gravel, that is 10 multiplied by 100. So you will get the modified percentages of sand, silt and clay, and according to after this calculation you will see that sand will be this percentage and this so on. And for C we have no changes in the original values given, okay, as the gravel percentage was 0. So for A, B and C you can calculate all these values, modified percentages of sand, silt and clay by using that formula given in this slide. Okay, so this is that results available. Now you have to plot it in the in this chart, this one, or in this one. Okay, so you will see that the results will be like A, gravelly clay loam, and this is gravelly silt clay, and this is clay, and this is gravelly clay. Okay, so gravelly clay loam A, look at in the chart first. Clay loam, where it is, this is here it is sandy loam, clay loam, sandy clay, this is clay loam. Okay, clay loam, but it is only clay loam. Why gravelly is written over there? Because in that soil sample we do have a percentage of gravels as well. So if it is falling in this block, okay, then it is clay loam, but if there are some percentages of gravels also available, then it will be gravelly clay loam. So the result or the type of the clay, the soil you have is gravelly clay loam as it falls over here. Okay, now coming to this second one, this is gravelly silty clay. So silty clay, look for silty clay, you can see it here, it is silty clay. So actually that modified percentages of the sand, silt and clay are falling in this block, so it is only giving us silty clay. But as there are some percentages of gravels also available, so you can say gravelly silty clay, and so on for the other one. And you can see in this one, and this C, clay sizes are like this is clay, so it is falling in this zone, this one, and this zone. Okay, but as there is no percentage of gravel available, so you can say only clay. The original name will be here, no gravels will be attached. Okay, so you can repeat this process for all types of clay. That was all from the textile classification, and this was also a numerical on this. And the word gravelly was added to classify classification of soil A, B and D, not C, because of the larger percentage of gravel present in each. Okay, so this is that explanation for what I told you. Now coming to AASHTO classification. Okay, finishing that textile classification, you have came to know that the textile classification was only classifying the soil according to its percentage of silt, sand and clay, or gravels as well. Okay, but in this AASHTO classification system we are also using the plasticity index and that liquid limit. Okay, so this is something addition to this classification system. Like this classification system is based on like more properties as compared to textile classification, so this will be more effective classification as compared to textile classification system. Okay, so here it is. First of all, before doing AASHTO classification system, you have to determine these things first. Number one, grain sizes and plasticity. Okay, grain sizes refers to gravel, sands and silt and clay. Okay, fractions that is passing through 75 millimeter or 3 inches sieve and retain on number 10 2 millimeter sieve is called gravel. Okay, and those particles which are like greater than 3 inches size are actually are greater than are having size larger than 75 millimeter are cobblers and boulders, and that are not actually classified in AASHTO classification system. So gravels can be classified, and that is having size 75 millimeter to 2 millimeter or 2 millimeter to 75 millimeter. Sand is that like those those particles which are having size 0.075 millimeter to 2 millimeter, and these are like retaining on 200 sieve and passing through 10. Okay, silt and clay are fractions passing through number 200 sieve. So all those particles which are passing through number 200 cu are having size less than 0.075 millimeter are classified as silt and clay. Okay, but this is just the requirement of using classification system. This is not classification system. Okay, then we have plasticity. So for plasticity, those soil which are having plasticity index less than 10 are actually called silty soil. Okay, this is silty one. And those soils which are having plasticity index 11 or more, and these are called clay soils, and these are can be classified over here in the AASHTO classification. And cobblers and boulders are actually those particles which are having size greater than 75 millimeters. So these particles cannot be classified according to AASHTO classification system. This should be removed from the record. But the size can be recorded and should be recorded for the values that are obtained from the sizes that are smaller than 75 millimeter. Okay, the percentage of boulders and cobblers should be removed and should be weighted and should be pointed out that this much cobblers and boulders are present in this sample. Now after getting these values, you have to use this table. Okay, this table or this table. Okay, we have two types of table. Number one, this table is actually for granular materials, and those type of material which are like granular materials, and these are like 35% or less of the total sample is passing through sieve number 200. Okay, so granular mean those particles in which 35% are less than 35% of the sample is passing through 200 sieve. So matlab you can say that those particles having size greater than number 200 sieve are almost 35% are less than this, then this table should be used. Okay, so coming to this one, how to use this table, and before going to this one or discussing this one, let me discuss this table as well. Here you can see that silt clay material, this table should be used for silt clay material where more than 35% of the total sample is passing through 200. So this is like silt and clay material, fine materials. For fine material you will use this table, and for gravelly material you will use this table. How to use this table? Now let's go through it. Okay, we will discuss it in the next lecture as well, but let us get a start on this, how to use it. Number one, we have different groups available, A1 group, A2 group. Okay, then we have different subgroups of A1, A1A, A1B, and A13 is also, sorry, A3 is available here. A2, 4, A25, A26, and A27 are the subgroups of A2 group. Okay, then we have in the next picture we do have these many other groups available. Okay, and soil can be classified under these groups as well. Okay, first of all, let me tell you about these groups first. Sieve sizes, sieve analysis. From the sieve analysis you will determine number 10 sieve, how much of the percentage is passing through number 10 sieve. You will also determine how much percentage is passing through number 40 and how much it is passing through number 200. So it will be obvious, you will calculate it and you will see whether 35% or less material is passing through number 2. So then you will use this table. Okay, so this number 200 sieve passing percentage is also important to select the table. Okay, so first of all, when this table is selected according to this requirement, then you will go through these values. Okay, number 10, for number 10 size, if we have the percentage or the percentage of the size passing through number 10 sieve is 50 maximum. 50 maximum mean not greater than 50. Okay, it should be less than 50%. Okay, maximum value is 50. Okay, so mean you can say that number 10 sieve passing should be less than 50%. Okay, or it can be equal to 50% but not greater than 50%. And similarly 30% maximum for 40 and 15% maximum for 200. Okay, so if this is the situation, then your soil will be A1A. Okay, if this is the situation, the soil particles are having size that there is from sieve number 40 you are getting 50% maximum soil size, or you can say soil percentage passing through number 40 is 50%. Okay, so then, or the next condition is 25% for the sieve number 200. Okay, so your group is like this one. Okay, and for both of them, for the both of these A1A and A1B are fall under A1. Okay, the usual type of significant constituent or plasticity index should be maximum 6. So plasticity index cannot be greater than 6 for A1 group, and so on. Okay, you will classify all the soils according to these conditions. Here there is no condition given for sieve number 10. If you can see it here, no condition is given for sieve number 10. So mean whatever the value for passing through sieve number 10 is, it is not considered over here. You have to check only these three properties for A1B. It is 50, 25 and this 6. Passing through 40, passing through 20, 200 and plasticity index. Okay, in these further classifications 8 to 4, you can see that liquid limit is also given over here, and plasticity index value is also given here. Okay, and only number 200 sieve percentage passing is given. No condition is available for number 10 and number 40 sieve. Okay, so this is how to classify these types of soil according to this table. Okay, now coming to back to this thing, here it is. This is for silty clay. So first of all, you will check when more than 35% of the total sample is passing through sieve number 200, then you will use this table. As you can see, all these values are like 36 minimum. Mean number 200 passing is 36 minimum, 36 minimum, 36 minimum, 36 minimum. So if you have a percentage less than 35% for passing through sieve number 200, then you cannot use this table, because all the groups given here are having condition 36 minimum, 36 minimum and so on. Okay, and for this the liquid limit and plastic limit is obvious for all types of for all the groups. Okay, all the groups. Why? Because this is finer materials. So for finer material you will have the some value for liquid limit and plastic limit. Okay, but for granular material you cannot determine that liquid limit and plastic limit for all conditions. Okay, so then these first two groups are actually silty soil, and these second two groups are actually for clay soil. This group, this one A7, is further subdivided in two groups, A75 and A76, A and B. How to do this, how to classify according to these two groups, I will tell you in the next lecture, inshallah. This is all from this first lecture, and in AASHTO classification a lot more things are also we need to discuss in the further lectures, and we will discuss the group index in the first lecture, and then we will discuss the unified classification system as well. So again I am telling you the AASHTO classification system is still continue, and we will discuss it further in detail in the coming lectures. Okay, thank you for watching. Assalamu alaikum.